Good morning, guys. Last time we focused on algorithms and we understood that our algorithms can be expressed in either pseudocodes or the use of a flowchart. Today what we're going to do, we're going to dive down a little bit deeper into writing algorithms, and we are going to look at some of the control structures that we can use as part of our algorithms. In all of the algorithms so far that we have dealt with, we have used a control structure known as a sequential structure. There are three types of control structures. We have sequential structures, we have selection structure, and then we have loops. As I mentioned earlier, the structure that we've been using so far has been sequential structure. Now, sequential structure will include input statements, output statements, assignments, for example, assigning a value to a variable, calculations, and prompting statements. So far, we have encountered all those constructs in our code. Now, the sequence structure, as its name implies, allows us to execute codes in a sequence. So if we were to look at one of our algorithms that we worked on, we realized that each of our code is executed in a sequence. So for example, if we look here on the screen, we'll see that we input one number, we input a second number, we input a third number, then we find the sum, and then we output our answer. So everything is executed in a series, in a sequence. An example would be putting on your shoes with socks, right? So the first thing that you would do is put on your socks. Next, you put on your shoes, and then you tie your lace, right? So that somewhat is a sequence of instructions. It has to be followed in a particular sequence. So you must put on your socks, then your shoes, then tie the lace. There's no other way you can do it. In terms of cooking, let's say for example we're going to whip up some macaroni and cheese. The first thing that you do is you turn on your stove. Yes, you add water to your pot, you bring the water to a boil, right? And then you pour in the macaroni. You bring that to a boil. You check to see if it's cooked, and then turn off the stove, drain the macaroni, and so on. Right? So basically, you have to follow that precise step. So that is basically a sequence. So at the end of bringing our mac and cheese to a boil and ensuring that it's cooked, of course, we drain the water. At that point, we will now apply our cheese, right? Now at that point, we're going to look at a different structure. We're going to look at what you call a selection structure, right? So we first look at a sequence structure whereby we had to do or we had to perform some instructions or execute some instructions in a specific order, right? We had to light our stove, bring the water to a boil, and all that stuff. So that was what you call a sequence. We had to do it in a sequence. Now we come to a point where our mac and cheese is now cooked, the water is drained, and now we have options. So those are selection structures. So at that point, you put your cheese, because mac and cheese we're cooking, so you must put cheese, right? But here's it. You have an option of adding milk or butter. right? So for the most people I know, after adding the cheese, they add milk, right? But there are some people who prefer butter. So that's what you call a selection structure. It gives you an option. It gives you a choice. You can either go that way or the other way, right? But what if we have only one choice? For example, we have no butter. Then we have only one choice. And the choice would be either we add milk or nothing else. No milk at all, right? So again, this will reflect the if statement. So if would be, if you like milk, we would add milk, because that's the only option that you have. If you don't want milk, then our process is done. Nothing else is done, right? Your macaroni is served as is, with only cheese, right? But if we have a choice between milk and butter, that is somewhat like an if-else statement, where you say, if you like milk, milk will be added. If cheese, then cheese is added, right? So we're looking at the selection structure, and there's two structures we look at: the if statement and the if-else statement. So if there's only one option, use the if statement. But if you have the option between two different choices, use the if, then else, the if-else statement, right? So let's see how we express that in pseudocodes first, and then we'll look at how we express it using a flowchart. Let's go to our first problem that we had. The problem was to design a program that accepts 3 numbers from a user, right? We would find the sum and then would display the total as an output, right? But in this problem, we're going to look at the same problem really, but with a little twist to it. So it says that to design a program that accepts 3 numbers, find the sum, and if the sum is less than 10, display low, right? So let's see how we express that in our IPO table. So the inputs remain the same, because it says that we should accept 3 numbers from the user. Our output is different, because we're not asked to display the sum as an output. We are asked to display low if the amount or the sum is less than 10. So how do we express that in codes in a process? So we say if answer, which is the sum of the numbers, remember the answer will hold the value because it becomes the variable. So if the sum of those numbers is less than 10, then, right, then we say print and we say low. Now, something to bear in mind. We have low within quotations, and that means the reason for that is because low represents a string of characters, right, that would be printed on the screen. So always remember, when we're looking at a string, we always put quotations, right, to show that it's a string. If it was a variable, we would just use the keyword or the variable name, right? As we did in the last problem, we actually had answer as our variable, and in the output we have answer, which would be the variable that holds the string or whatever in there that has to be displayed, right? So let's look at the process again closely. What was added after we find the sum of the numbers? we say if the answer, and we use the less than sign, right? If the answer is less than 10, then, right, then print low, and then our output would be low, right? All right, so and that is using the selection structure, if then construct. Now let's look at the if then else construct. So let's take it again, if then else construct. So here's the problem again. Design a program that accepts 3 numbers from the user. Find the sum of the 3 numbers. If the sum is less than 10, display low. Otherwise, display high. Right? So again, our input is untouched because we supply the same numbers, right, as our input, or the same value, the same variable, sorry. All right, so for the process remains the same. We execute the first portion of our code executed in the sequence, and then we say if the answer is less than 10, then we print low, otherwise we print high, right? So remember, the IPO table is to decompose our problem into smaller chunks or into small blocks, right? So we have it there. If the answer is less than 10, then print low, otherwise print high. And then for the output, we have high or low, right? Because it can be either or. Based on the user input, you have the output of low or high. And again, bear in mind that the outputs are within quotations. That means that we're printing off a string of characters, right? All right, so now writing our pseudocodes. Expressing our algorithms using pseudocodes is pretty simple. We already know how to write the sequence structure. So that is an example of a sequence structure, everything in black. So we have the first thing would be print. So basically we prompt the user to enter their first number, and then read would be accepting the number in memory. We have that done, repeated again, and we have repeated again, right? So we have it 3 times there. So they're done in a sequence, one after the other, as we go down. And then we reach where it says answer, and the answer is supplied after adding num1, num2, and num3. Then we reach a selection structure. Now at that point, we check if the value of answer is less than 10, and then we print low, right? So just look at that pseudocode closely. We say we use that keyword if, right? Because we're writing a selection structure. And remember, at the end of it, we write end if. It means that we end in the if statement, right? So that's something that you need to remember. So if you write in a if condition, you start with the keyword if, and you end with end if, saying that you have ended the if statement, right? Always remember that. The next thing to remember is that, or to note, is that the code is actually indented, right? It means that, for example, print low is within that block of code, right? So we always do an indentation. Okay, so let's look at our if then else. All right, so first we have our selection statements. We have, of course, we must start with our start. So we start with the start keyword that says the start of our code, start of our algorithm. Then we go ahead with our sequential statements, print, read, and so on. And we go ahead in sequence. So we go all the way down, executing each line of code one at a time. And then we go ahead and we find the sum of the numbers, and we assign it using the assignment operator, right? So this is called its assignment operator. And then we assign it to the variable name answer. So it now holds the value of the sum of the three numbers. Now, here we come to our selection structure. And this selection structure is a if, then, else, right? So basically, if you look at the structure itself, you see the if, right? You see the if statement right there. So we have that keyword, and then we have else, and we have end if, saying that we have ended the if statement. All right. So always remember again, if we start with if, we have to end with end if, meaning that we end in that code block or that structure, right? So again, you see the indentation. If the answer is less than 10, we indent to show that that code belongs to the inner block of that if statement. And then we say else, which is our next option. We can go ahead and print hi, right? So you can take some time to just look at it, make sure you understand it. And we're going to go ahead and express it now in a flowchart. So we're introducing a new symbol in our flowchart, and that is the diamond, right? The diamond shaped object or symbol. So this symbol represents a decision, right? So all the process remains the same. As you can see, the flow of the arrow, the sequence, the arrow shows the flow of the execution of the code, right? So if you realize from start, the execution is one after the other, right? But when it comes to the decision symbol, it has two arrows. It has one arrow labeled yes and one arrow labeled no, right? And in the center of that decision box, we have if answer is less than 10. So our decision is being made based on that condition, right? So we say if answer is less than 10, then if it's yes, we execute the next line of code, which is output low. But if our answer is no or false, then it takes the next path, which is end, right? Because it means that our program has come to an end and we're not executing anything. We're not executing the next line of code, which is output low, right? So in that case, nothing would be outputted on the screen. So if the total or the sum of the numbers is less than 10, nothing is less than 10, it will output low. Other than that, if it's more than 10, then nothing will be outputted on the screen, right? You'll be staring at a blank screen. The program will have ended. And again, that's a if-then statement. So we're looking at the if-then structure. So the next slide is going to be if-then else sort of structure. So let's look at it. So with the if-then else structure, it starts up again with a sequential statements. It first prompts the user to input a few numbers. Then we go to the next step, where it sums the values of the numbers and return the answer. And our third step, we see again the introduction of our decision box, right? Again, the decision is the same. On what do we make the decision? On whether the answer is less than 10. Now, with that problem, we have two options. And we can choose either one based on the condition in our decision box. So, if the answer is less than 10, then we output low. And low again in quotation means that we output in a string, right? So if the answer is not less than 10, then the next line of code will be executed, which is high, right? So these two codes cannot be executed at the same time. It's either one or the other, right? And here you'll see a new symbol, and this is called a connector. A connector. So basically, nothing has to be placed in that connector except that our lines connect to that connector and go to a common part of the program. In that case, it would be N. Because after we output on the screen, the next step really is to end our program, right? So the connector is just there to connect two sets of executions that end in the same place. The alternative to that, we could actually point the two arrows to end, right? But it's not practical. It is more practical to put a connector, connect them together, and have one arrow going to the end. So I do not want to make that video very long, so I will stop for today. And the next time we meet, we will look at loops, which is our third structure. It's a condition structure. So we look at loops. So far we look at sequential structures, and we say they include input statements, output statements, assignments, as we have here. They will include calculation statements and prompting statements, right? Now, selection statements basically gives you an option, and there are two main type of selection structures, and they would be if then, which tells you you have one option. You can either choose that option or nothing. And we have if then else, where you have two choices, where you make a decision based on some criteria. If yes, then a specific line of code would be executed. If no, then another line of code will be executed. And then we got introduced to a new symbol, which is the connector and the decision box. So feel free to make a comment below on the video if you understand it. If not, again, put a comment and let me know so I can go ahead and try my best to help you. You can always review the video, replay it to make sure that you get the concept, because those concepts are really critical.